Hello everyone, good morning. Welcome to Nrcm. This is Shravani and I am going to explain about operating system of Unit 3 and the topics are deadlock recovery and process synchronization. So coming to the deadlock recovery, actually if you want to recover from the deadlock, there are two approaches of breaking a deadlock. So first one is process termination and second one is resource preemption. What is process termination? Process termination is to eliminate the deadlock. We can simply kill one or more processes. For this we use two more methods, and thus two more methods are, so first one is abort all the deadlocked process, and second one is abort one process at a time until the deadlock is eliminated. So what is the meaning of this abort all the deadlocked process? It's like here we'll abort all the processes which will create the break but with a great expense. The deadlocked process may have computed for a long time, and the result of those partial computations must be discarded, and there is a probability of recalculating them later. So we are here will be, like aborting all the deadlocked processes, but it is little bit expensive, but even though, but we can recalculate them later, okay, after avoiding the deadlock. So next, coming to the, like, abort one process at a time until the deadlock is eliminated. Here what we'll do, just we will abort the process. So we'll, if there is a cycle, if the cycle is found, we will eliminate a cycle. Okay, we'll eliminate or abort only one process so that the deadlock will be eliminated, and then we can recalculate the process so which has been aborted. Okay, next is second one is resource preemption. Like, to eliminate the deadlock using resource preemption, what we do is, like, we preempt some resources from the processes and give those resources to another processes. This method will raise three different issues. So that first issue is selecting a victim. So here we must determine which resource and which process are to be preempted, and also the order to minimize the cost. And the second method or second issue is rollback. We must determine what should be done with the process from which resource are preempted. One simple idea is total rollback. This means abort the process and again restart it. Okay, and next, third is starvation. Starvation is, like, in some systems it might happen that some process is always picked as a victim. Like in some operating system it might happen, or the situation may occur like this, always the same process is picked as a victim. So that results, the process will never complete its designated task, okay, or destinated task. So this situation is called as starvation, and this starvation must be avoided. One solution is that a process must be picked as a victim only a finite number of the times. So they, like, we should mention the time, like, if the process is selected for two times and the third time the same process cannot be selected as a victim. So in this way we can avoid recover the deadlock. And next we are going for the process synchronization. Like, what is process synchronization? So process synchronization means, so, sharing the system resources by the process. So here we share the system resources by the process in such a way that the concurrent access to shared data is handled, thereby minimizing the chance of inconsistent data. So what happens here? So to ensure the synchronized execution of cooperating process synchronization was introduced to handle these kind of problems that arise while multiple process executions will occur. Some of the problems are, like, we'll be discussing in the next slides. So I hope you all understood. Like, process synchronization means, like, we'll be sharing the system resources. Okay, the system resources will be shared by the different processes, so in such a way that, so both the systems will be using the shared data. So it will minimize the cost, and we can, so maintaining data here, maintaining data consistency, it demands the mechanism to ensure synchronized execution of the cooperating process. Okay, this is all about the like process synchronization. And next, entering into the critical section problem. So what is a critical section problem? A critical section is a code segment that accesses the shared variables and has to be executed as an single action, as an atomic action. So means the group of cooperating processes at a given point of time, only one process will be executing its critical section. If any other process also wants to execute its critical section, it must wait until the first one finishes. So here you can see the diagram. So suppose this is the entry section. If any of the process wants to enter the critical section, so first it should pass this entry section. Okay, so it should pass this entry section. Once this entry section it has been passed, when this will be locked, and it will enter into the critical section, and it will execute the, and it will execute the program after entering into the critical section. Once after finished, whenever it exits, whenever it comes outside, then what happens, next process can enter into the entry sections. Until then the process will be in blocked state. Okay, this is about the critical section problem. So if you want to give a solution to any of the critical section problem, so first you need to consider the mutual exclusion. So as we discussed, mutual exclusion is like no other process can be executing in the critical sections. So if there are, if one process entered into the entry section or critical section, no other process should not enter into the same critical section. Okay, next is progress. Progress is like if no process is executing its critical section and there exist some processes that wish to enter the critical section, then the selection of the processes that will enter the critical section next cannot be postponed indefinitely. So the progress is like if any of the process is not performing the execution, so some processes they might enter into the critical section. So once the critical section process entered into the critical section, and the remaining process cannot enter into the same critical section. So next, coming to the bounded wait. Bounded wait is like after a process makes a request for getting into the critical section, there is a limit for how many other processes can get into the critical section before the process request is granted. So after the limit is reached, then system must grant the process permission to get into its critical section. So here for waiting also there will be some kind of bond, and so for waiting also there will be some kind of bond. If the bond is fulfilled, so if the limit is reached, then the system will be granting the process permission to get into its critical section. Next, we are going to see about this solution to critical section, like using locks. So like critical section using the locks is like, suppose for example, if there is one process, so if there are the process called as P1 and P2. There are the process called as P1 and P2. So if P1 is in the entry sections, so what happens here? So once a P1 enters here, so this will be locked. This will be locked means, suppose here the lock can be set 1 if any of the process is inside the critical section. So the lock will be set to 1 here. So once the P1 enters and it will execute the critical section code, then again what happens, once here it is released, once the P1 releases the lock, again here the lock value will become, it will change from 1 to 0. It will change from 1 to 0. So whenever the process sees this 0, then the next process can enter into the entry section. So once the process P2 enters into the entry section, again this lock will be set to from 0 to 1. So once the process P2 releases the lock, then again it will become the 0. Then it will be giving chance to the other process to enter into the critical section. And that's it. Thank you.